So to start off, I just wanted to just briefly go through some things with you about the different types of growth models that you came across in that module. And so they talked about linear growth and then exponential growth and logistic growth. And so those are the ones that we're going to be focusing on. And these formulas that are given here, like this recursive form, explicit form for the linear growth, these will be given to you. So there is going to be a formula sheet this time. And so a lot of the formulas will be on there, so you don't have to worry about getting those memorized or anything like that. Okay, so as well as for exponential growth, the recursive form and the explicit form will be on there, and also the logistic growth. Okay, so just so you know, all of those will be put on that formula sheet. And that formula sheet is going to be the very last page of your exam. So you can just, so you don't have to like keep flipping back and forth and stuff to the formula sheet. You can just rip that back sheet off and just have it on your desk there, just so you can see it a little bit easier and stuff. So just so you know, it will be the last page on there for you. Okay. So I don't want you to overlook that. Get to the end of the test and go, oh, there's a formula sheet here and I didn't even notice it. Definitely don't want that to happen. So okay, so were there any specific questions that you have? I mean, we're going to do some examples on how to work with these recursive and explicit forms of these growth models. But was there anything on here that you can see that you're like, oh, yeah, I had a question about that when I was going through it?
I do have a question. I don't know if it's specifically to this, but I think what I'm most worried about is with all the formulas that we've learned with the growth model and finance, like to know exactly which ones to put in for the problem. I think
Yeah.
it's kind of overwhelming a little bit.
Yeah, it is like knowing which ones to use when. And so that's why I am giving you all the formulas, and it's not just the formulas that are on there. Like it will say like, linear recursive, formula, linear explicit formula. So they will be labeled as well. But understanding what the different parts of these are as well is important to know. And so when we go through some of the examples, sorry, I got a big yawn. And I'll talk about, what those different things mean in there and how you can recognize which one you're supposed to be using. Is that what you're worried about
Yeah,
mostly?
yeah, that's perfect.
Okay.
Thanks.
Okay, great. All right. Well, let's take a look at some of these then, and then we might, take a look at a few more or something if there's questions from homework or something. And I will send these reviews to you as well so that you'll have them if you want to try and like rework through them again, that you will have them to look at. Okay. All right, so let's look at this first one. The population of Smallville grows according to an exponential growth model. In 2010, the population was 8,354 and has been growing at 3.5% each year. If this continues, what will be the population in 2030? Okay, so when we're looking at this, the way that we can tell if we're going to be using the recursive or the explicit form is, remember, the recursive always relates to the value, like either like a previous value or the next value. And if it doesn't give us that, then we need to use this explicit form. And so we can see on this, we're not given, we're told what the population actually is in 2010. And so when we're talking about this, so we're gonna be using this formula right here, okay, that P sub n, let's see if I can maybe I'll just write it down here so it's a little bit easier to see. See. All right, so the one that we're going to use on this is P sub n equals P sub 0, and P sub 0 means like the start amount, the initial amount, like the initial population. And so if you kind of think of that as the start amount, that kind of is helpful, I think, on this. And then 1 plus R, which is the rate, and N is the time. All right. And notice up here that, R is the growth rate. And then when you're adding the 1 to it, so that 1 plus R, that's called the common ratio of it. But just to make sure you're kind of clear on that, what that is. So, and so does everybody see why that would be the one that we'd be using on this one? Because we're not given a previous amount, right? So this, if we have P sub n, then this P sub n minus 1 needs to be what that previous amount was on it. And we'll get to some that have those on there. But this one, we're not given that. But we are given this initial value. So I'm going to write some of these things down here. So notice the things that we need to know here are the P sub 0, and we need to know the rate, and we need to know the amount of time, right? So P sub 0, what would that be in here?
8354.
Yeah, so that's our start amount, our population start amount. So 8354. And then our rate, if we change that rate to a decimal, what would that be? Because right now it says it at a percent. So how do we change a percent to a decimal? Remember, we're just going to move that decimal point back 2 places, or divide by 100.
By 100?
Yeah. So divide by 100, or just move that back 2 places, right? So that would be 0.035. So we definitely want to make sure that we change those percents to decimals before we're using them, right? And then when we're looking at this, I want you to kind of, think about, so this, this 2010, that's our start date. So it's kind of like, that's when N is 0, right? That's our start date. And then this is the date that we're looking at, right? And so really, to figure out what our N is for this, we need to subtract those 2 things, right? So 2030 minus 2010 is going to be 20 years is what we want to use for our N. Is everybody okay there with me? Make sure you're speaking up if you have questions. You're like, where did you get that number from, Becky? So those are the 3 variables that we have in this. And so I looked to find those in my question, and I was able to find them. All right, so now if I put this in, oops, let's see. Hold on just 1 second. Okay. So if we have this, so we'll have P sub n equals our P sub 0, which is 8354, times 1 plus my rate, which on this one is 0.035, and then raised to the 20th power. Okay, so as far as like on the test, I say, show your work. Now, for me on this exam, if I can see, like, I want to see this, I want to see what number, like what formula you're using, first of all, and what numbers you're putting where. And then from there, I'm really okay if you just use your calculator to figure out what the answer is, but I need to see this. Because if I don't see that, then I won't be able to give you any partial credit. You will just miss it. And if you don't have it on there either, you won't get any credit for it. So make sure you're writing, showing me where you're getting that answer from. All right, so if we put that into our calculator, and like I said, like on this calculator, I can put that whole thing in there. Like I don't even have to, like do it separately or anything like that. So make sure you know how to use your calculator. And if you have some questions about using your calculator, you can stay on at the end and I can, talk you through some of that if you're like, I am not getting the same answers that other people are getting on that. Okay, so for me, I came up with, and it says on here, oh, it doesn't say where to round to. On the test, it definitely will tell you where to round. So we'll just round to the nearest nearest person since it's dealing with population. So I get 16,622, but then it says 0.6, so really it's going to be 23. Whoops, so end in a 3. Okay, so people in 2030. All right, that's going to be an amount of people there. Okay, questions on that?
Yes, I got a different answer, which is 1.2393 17956.
Did you multiply it by 8354?
Yes. So I did what's in the parentheses first. Then I did the thing where you can do the 20.
Raise it to the 20th power?
Yes. And then I multiplied it by 8354.
Try it again because you got like a really small number. There's just no way. So it should be 1.035 raised to the 20th power and then press equals after that. And then times it by 8,354. Yeah, make sure you're like press equals. That's probably like if you can't put the whole thing in your, like calculator, just knowing like after you raise it to the 20th power, you got to press your equal sign, press enter before you multiply it.
Yeah, I'll stay after.
Okay.
So
okay. Okay, sounds good. I know, because really that is going to be, the trickiest part on some of these is just making sure you know how to use that, your calculator correctly. If anybody else has like a question on the calculator, please, please, please make sure you stay after and let me help you with that, okay? Okay, so let's look at this next one. So consider an insect population that starts at 50 insects and grows by 12 insects every week. So when I'm looking at this, there's no percent, right? It's not a percent change like I had up here. And that percent change is telling me that it's exponential. It also told me right in here it was exponential. But on this one, it's not telling me specifically that it's linear, but I know it's linear because it's not increasing by a percentage amount. It's increasing by like an actual amount of insects. Okay, so that's kind of what's telling me it's linear. And so it says find the recursive formula. So we want to use the linear. all right, recursive formula that models how the insect population grows over time. So if I'm looking at this, let's first of all, like figure out what P sub 0 is, P sub 1, and P sub 2. So what is my start amount? Remember, P sub 0 just means my start amount. What's my start amount in this?
50?
Yeah, 50, right? It says population starts at 50 insects. So that's going to be my P sub 0. And then P sub 1 is it growing by 12 insects per week, right? So I'm going to take that 50 and add 12 to it to figure out my next one. So that's going to give me 62. All right, and then again, I take that 62 and I'll add 12 more to it because it's increasing by 12 each week. And so that would give me 74. Okay, so first just kind of listing out what some of these are, all right? And then, let's see, it didn't ask me to write that recursive formula, but on the exam, it will have you do that. So let's just look up here again, right, on these recursive linear formulas, that's here. So it's saying P sub n minus 1 plus D. And that's basically what I was doing on here. I just didn't write it in, formula, in that form. So P sub n equals P sub n minus 1. And then the amount that it's growing by each week is 12. So plus 12. And so that's why, so I took this. That was the, like the previous amount, added 12 to it. 62 is the previous amount, added 12 to it to get to the next one. So if it asks for like a formula, a recursive formula, that's what you would be putting on there. Okay, that's the formula that we'd be using. But how to use it, right, just by adding 12 each time is an important part to understand. Okay, now it wants us to find an explicit formula to predict the number of insects in n weeks. So again, right, with our explicit formula, and again, remember these will be given to you on the exam, right? But this time we've got P sub n equals P sub 0, so remember that's the start amount, plus D, which is the amount that it's being increased by every week, and n in this case is the number of weeks. So when we're talking about an explicit form, we're basically putting it, so linear formulas, if we have it like y equals mx plus b, all right, they're going to be kind of in that form. But, it looks a little bit different for what we're, saying. We're saying like P sub n equals, and we're calling the amount that's changed there D, and n is the time. And then B on our, y equals mx plus b, that's our start amount. So plus P sub 0. So, on the one that's listed up top, it has it as P sub 0 plus D times n. But those are the same thing, right? These mean the same thing. We can switch where P sub 0 is as long as D and n are still being multiplied by each other. Okay, so anybody have an idea? How would we write an explicit formula then for this? So what did I say the start, or P sub 0 is the start amount. So what's our start amount?
50.
50. And then plus D represents what? What number is that in this one?
12?
Yeah, 12. It's the amount that it's going up by every week. All right, and then we don't know what n is. N represents the number of weeks. All right, so we're not, when it's asking us to find like a formula, it's not asking us to find an overall answer yet. It just wants us to write this down. Okay, but now on this one, how many insects will there be after 15 weeks? So what do I do with this 15 now?
Put it into the formula for n?
Yeah, just put it right in there for n, right? So, and usually the way they write it is like this: p sub 15 equals 50 plus 12 times 15. All right, and that is just telling us, that this is at the 15th week. All right, and so then go ahead and, multiply that and add those together. What do you come up with there?
230?
Yep. So 230 insects, all right, by week 15. All right. And of course, this is assuming that the insects are not dying off in that time. And there's like a lot of assumptions kind of being made in some of these like that. So, Okay, and then how about this next one? How many weeks will it take for there to be 350 insects? Now, where are we going to put that 350?
Instead
In front
of
of it?
the 50.
Yeah, so the whole thing, right? P sub n, that whole thing. So we're going to put 350 equals 50. See, I'm just using this formula here. 50 plus 12n. And now I'm just going to solve it for n, right? So start by subtracting the 50 over. Kind of run out of room here. So I have 300 equals 12n. And then if I divide both sides by 12, what do I come up with?
25.
Yep, 25. And if it on your test doesn't come out to be like a whole number answer, it will tell you where to round your answer to. So make sure you're looking closely for that. Okay, watch carefully where it's telling you to round. So, so n is saying at 25 weeks. All right, there is 350 insects. Okay, so that's what we're doing there. All right, questions on that second problem there? So that's basically like all this stuff talking about linear growth, right? Whether, so we talked about the recursive formula in there, and also how to write the explicit formula, as well as how to use the explicit formula to find the different things that we're doing. Okay. All right, so how about this number 3? A population grows according to an exponential growth model with p sub 0 equal 400 and p sub 1 is 650. What is the growth rate? So notice that this is exponential growth, right? Anybody have an idea? How would we figure out what R is?
Do you divide them by each other?
Yeah. Yep, you're going to divide them by each other. Which way are we going to divide it?
Big over small.
Okay. So, so 650 divided by 400. So what is that going to be?
$1.625.
Okay, let's see. So does that seem right? 1.625. That seem like the growth rate. What do you guys think? Let's go back up here for a second because I just want to make sure. All right, so the growth rate is this number here, right? So we actually, that number is going to be representing a percentage, right? And so if we're looking at that, that's saying like, you know, basically growing by like 162%, right? And so if it's, you know, and it is going up from one to the other, right? So that seems okay. But you know what, I'm thinking about this. Okay, let's look at, we'll come back to that in a second. What about, how would we write a recursive formula then for this? So remember, it's for exponential growth, so we're looking at this one, right? I'm kind of thinking, I'm trying to decide. I don't have, I mean, there's not going to be anything quite like this on the exam, and I thought that I had different ones on there. Not really what I was thinking we were going to be doing. So I think maybe we will skip the rest of it because we can find it, but most of the questions on the exam are going to be more like story problems, you know, where you're like picking information out of it. And so I just want to make sure that we're doing some more of those. So let's, and this number 4 is a little bit like stuff that we're going to be doing in the next module, in the finance module. So I think maybe what I'm going to do here, well, let's do this because I already have these pulled up, and then we're going to come back. I'm going to do just do a couple more growth models problems with you and stuff. But let's get through the other part first. It seems like most people were having a lot of questions about the finance part of it, and a lot of it has to do with maybe your calculator, but not always. It's usually like, which formula am I using when? And so I think that's really a good thing that I want to make sure that we focus on for this. So these are the formulas that are going to be given to you. Okay, and notice that we have two different things here, right? So we've got this, well, this is just a regular compound interest. So if you are given, maybe I'll write a couple of things on here. If you're given like one lump sum, so this P sub 0 is just saying like you're putting like one amount in to the bank, and then you're just letting it earn interest on that one lump sum, okay? I just kind of put it like that, one lump sum, right? I hope that makes sense to you, what I mean by it. Where annuities, you're putting money in every month, right? Like maybe you're putting $500 each month in there instead of it just being one lump sum, right? And that's the biggest difference between those. So when we have this annuity savings plan, P sub N is how much you're going to end up with at the end of that time, right? D is the amount of money that you're depositing in every month. And then, you know, some of these other things kind of, you know, are similar, you know, to all of these different formulas. Maybe I'll put a couple of things up here, right? So D is the amount deposited. Kind of means something different in these ones down here, but I will talk about that in a second. So amount deposited, and then the R is the interest rate, And then K is the number of times compounded in 1 year. And most of these are going to be like the K, more often than not, is going to be 12 unless it tells you otherwise. So most of the time we're going to be using 12 for that, because it's being compounded monthly. Then that capital N there is the number of years. And I think that's pretty much it on all of these. And so, I'll put P sub N is like your end amount after N years. And then there's a P sub 0, which is your start amount. All right, so just understanding what each of those things stand for. Of course, like the formula is only as good as if you understand what the different parts of it mean, right? So make sure each of those are making sense to you, what it is, okay? And so on this one, that annuity savings plan, I solved it for D, and I got this, okay? So this is just this formula rearranged so that D is by itself. That's this formula. Okay, so if we're trying to just figure out, like if it is asking you how much, do you need to deposit, or like how much do you need to put in the, in the account every month in order to end up with, some larger lump sum there, okay? And then down here, payout annuity, this is like if you're withdrawing for retirement, or it's also dealing with payoff for loans, like if you're paying off a mortgage or something like that. Okay, and I hope all of you have done that mortgage project and that you understood it, because there's definitely going to be questions on the exam that are similar to those that were on there. I mean, it's not going to be as long, obviously, but there's definitely going to be some questions on there. So if you understood that project pretty well, hopefully this, won't be too hard of a exam for you on this part, okay? Okay, but again, all of these formulas will be given to you, okay? You don't have to memorize any of these, okay? And so down here, instead of D being the amount deposited, when we're dealing with it in this one, it's the amount withdrawn, right, for your payout annuity, like for retirement, how much you can take out every month, right, or the monthly payment for a loan, right, if you're like how much you would be, like your mortgage payment is, kind of a thing. Okay, so let's look at a few of these, and like I said, like we're first going to try and go through, we're going to look at them and try and decide which type of a formula, which formula do we want to use on each of these questions. Okay, so that's going to be kind of the first thing that we do, and then we'll go back and solve them, because knowing which one to use is super important. Okay, so let's look at this first one here. Consider you deposit $450 a month into an account earning 6.25% APR compounded monthly for 30 years. How much would you have in your account? How much did you deposit, and how much is in interest? Okay, so which kind of formula are we going to be using on this one? So there's kind of I guess the thing to look at here is you're depositing $450 a month, right? That's an important part of it, because remember, on this compound interest, that's just one lump sum, right? You won't be using this formula if it's telling you like you're depositing so much per month. Okay, so which one would we be using on this?
The annuity
Yeah.
savings plan?
Yeah, this one right here, right? So I'll just put on there, it's going to be the savings annuity. And again, we can tell that it's going to be an annuity because annuity does, I mean, that's exactly what it means is you're putting a certain amount in per month. I mean, it doesn't have to be per month. Sometimes, you know, like you could put it in like every 2 weeks or whatever, but you're putting, you know, the same amount in over a certain amount of time. Okay, so this is the savings annuity. Okay, everybody seeing that? Why that's the one we would be using? All right, and just look at kind of the first, you know, like how much would you have in your account? And we'll come back to it. How much did you deposit? How much is there in interest? So we'll go back and solve that and show you how to do that. Okay, how about number 2? Now suppose 10 years later, your friend wants to retire at the same time as you with the same amount of money at the same 6.25 APR. What amount will he have to deposit each month to match the value of your annuity? Okay, and kind of the thing to look at on this one is, what is the question asking? How much will he have to deposit each month? So we're looking for like a deposited amount, right? And so that's going to be this one, this deposit for the savings annuity. We're trying to figure out what D is this time because we're trying to figure out how much money is he going to have to put in each month, right? He's behind, so he's going to have to put in more than you put in to make up that amount because he wants to end up with the same amount you have, right? But that's what we're trying to figure out on that one. So that's going to be the deposit of savings annuity. Okay. How about this third one? You deposit $4,300 in an account with interest of 6.5% APR compounded monthly. How much will there be in 8 years? How much will be interest?
Would that still be savings annuity because you're putting in monthly?
So are we putting in a certain amount each month? What do you guys think?
Is it the one where you said that will give you just one big amount?
Yep, that's going to just be that lump sum one. So it's just the compound interest one because it's just telling us like we're putting $6,000 in rather than, you know, putting like a little bit in each month. We're just putting a big amount in. Maybe you get like your refund or something, right? Your tax refund. And you decide, okay, I'm going to just put all of that money in to a savings account to have it grow interest. So that's kind of the difference in that one. So yeah, so this one would just be using that compound interest formula. Okay, and I'm going to share this document with you. I'll have you look at, maybe look at number 4 and number 5, and let me see if I can get this put in the chat for you so that you guys can pull it up. It might be a little bit easier. Actually, I'm not sure if I sent it as a Word document. See if you can open it. I might need to save it as a PDF and send it that way, just because it might get weird. Let's see. Okay, and there's the PDF of it too, in case that Word document one. Sometimes they, stuff gets a little bit wonky, but. All right, what about number 4 then? How much money can you withdraw each month from annuity with $750,000 over the next 30 years if interest is 8% APR compounded monthly? So which one would we be using on that one? So it's the important part here, right, is can you withdraw each month? Whoops. All right, so looking at our formulas here, right, this retirement withdraw is what we're kind of looking at there, right? So that payout annuity. So are we trying to find, so we want to know the withdraw amount, but on that, that's really like that D. It's, D is the amount withdrawn. Does everybody see that? So we would be using this second formula here. So, and I lovingly call it the pork formula. Can you see why? It looks like it says pork there. Okay, so because it's kind of like hard, it gets kind of wonky and like, how do I say which one it is, right? But so I'm just going to put down here that that's going to be, we're going to use that pork formula. All right, because we want to know how much they can take out each month, right? It's like, how much are you going to be able to take out for retirement each month? Okay, what about number 5? What is the principal needed to fund an annuity that pays you $2,000 per month for the next 20 years? If the APR is 5.15% compounded monthly. So principal needed, right? So this is saying you're going to pay yourself, right, $2,000 a month. That's how much you want to withdraw. So you know what D is, right? So we're not trying to find D on this one. We want to know how much money you've got to, put in originally so that you can take out $2,000 a month. And so that would be that payout annuity. Right, this is going to be this formula here. And notice that the payout annuity formula and the amortized loan formula, they're the same formula, okay? So these are both, but in this case, since we're dealing with annuities there, that's what we would say. So we're going to use the payout annuity formula. Hey, whoops, I forgot an I in there, but okay. And then the last one, you find a townhome you would like to buy for $250,000. You will put 10% down on the home and finance the rest for 30 years. All right, so there's going to be parts of it that you have to do, just like on that, that project that you did. Okay, but this is the, part that we want to figure out, like what is the monthly house payment, right? Is what we're really kind of looking for in this to help us figure out which formula we're going to be using. And so if we want to know what our monthly house payment is, right? That's what this is saying here. So we're going to use that PORC formula again. Okay, when we're trying to find that monthly payment. So remember, that's either if it's the amount withdrawn, right? So how much you are taking out for your retirement, or if it's talking about a loan and the payment amount. So we'll also use the PORC formula on that one. Okay. Is that making sense a little bit better for you? Like when to use which formula? Because I know that can be kind of tricky, right, with these, and just understanding when to use them. And if you can get that, like if you know which formula to use when, then it's just a matter of just like plugging the stuff in and having your calculator do most of the rest of it for you, right? Okay, well, let's look at a few of these here, and we'll see how long it takes. I know it's definitely going to be, I can stay on until probably 9 if you guys want, but I'll work through a few of these. Is there any of these on here that you're like, yeah, I remember those were ones that I really struggled with, either on the homework or anything like that?
I have one that I'm a little bit confused with, and maybe it's just putting it in my calculator, but was the formulas with the logs.
With the logs?
Yeah.
We're not
Especially, so when I was doing the mortgage project, I got through everything, but that last question with the logs, I struggled with a little bit.
Okay, well, I can talk to you about that after if you want. I will just let you know there will not be any questions on the test in this where you're going to be using those log formulas. Okay, so just these formulas that I gave you here. So you're not going to be solving for time or anything like that on any of the questions. So hopefully that's good news for you.
Yes.
You won't have to do that. So don't even study over that. But I can help you, work through it so that you know how to do it for the project and stuff if you want to stay on after. Okay? Okay. All right. Well, let's look at a few of these then. The ones that I think tend to be a little bit more, let's see, let's try doing number 2 first of all. And then we can kind of go from there. Let's see, is number 2 the one I wanted to do? Hold on just one second. Actually, let's do number 1, and then I want to do some of those ones with the PORC formulas. So let's do this first one. Okay, so consider you have $450 a month you deposit $450 a month into an account earning 6.25% APR, compounded monthly for 30 years. So this has some different parts to it, right? How much will you have in your account? So I'm just going to kind of put this as part A, right, where we're doing that. So we're using that savings annuity formula, and so if you look on yours to see it, and I will also that formula sheet, I can send that to you, but I am going to upload that to the exam 2 module so that you have it there, so you can see exactly what's going to be given to you on the exam, what the formulas are there. So I just haven't put those other formulas on there yet, the recursive and the explicit, so I was going to put those on first before I upload those. All right, so P sub n equals D, and D is our deposit, so that's going to be our 450 times 1 plus And sometimes you have to be really careful with your parentheses on some of these, right? 1 plus R over K. So my rate on this is going to be 0.0625, right? Make sure you remember to always change those to the decimals, right? It's being compounded monthly, so it's going to be divided by 12, right? And then raised to the nk power, so that's going to be 30 times 12. And then this is all divided by R over K. So that's going to be the 0.0625 over 12. And really, like, I mean, I don't know, like if you have access to, like a calculator like this, it's going to be so much easier for you because you can just put that whole thing in there. But remember, again, like I want to see what I have, like what you're putting in each place and stuff. You've got to show that first. And then if you choose to show other work on there, that's fine. But that is very minimum of what you have to do there. Okay. And so then there is like, I mean, with any of them, if your calculator, I don't know if you can see on here, but there's like a button that says like N over D. I know that's backwards, but that's like numerator over denominator. It gives you that fraction. That's so much easier if you have a button like that for these, because I start off and I just like make, one fraction right there at the beginning. And then I can put the stuff on the top and the stuff on the bottom and put, some of that in. So, all right, so let me plug this in and see what I come up with. You guys do it on your end. And then, oops, did I forget? Ooh, I did. I forgot something here. I didn't close my parentheses there. And that's because I forgot to put that. Do you guys see there's like that -1 after that? That's an important part of that, so I don't want to leave that off. Okay. And be careful on that -1 part, that you're not putting it like, because when you're writing it in here, it might actually like try and go as part of that exponent. So you got to arrow over after you do that 30 times 12, arrow over so that it goes down to where it's supposed to be, because you're minusing 1 off of that whole thing. And then let's see. Trying to think of all the different places where things could happen there. All right, so for me, so how much would I have in my account? I got $474,263.98 if I round it to the nearest penny. Is that what you guys came up with? Were you guys able to come up with that, or are you still trying to see if that's what you came up with?
How would you put that into your calculator if it didn't have that numerator denominator button?
So yeah, you'd have to do order of operations, right? So you'd want to start by multiplying first those together. So 30 times 12 is 360. And so I would start, you have to kind of like work from the inside out. So you'd first want to do that. You'd have to do your 0.0625 divided by 12. It equals, add 1 to it. All right, hit equals. Raise that to the 360th power. Hit,
How far should I round that up? Because when I do that, I get like 0.005208 and then threes.
so keep that whole thing in there. Don't.
Okay.
Yep,
Gotcha.
just keep the whole thing in there, and then subtract 1. Hit enter. Times it by 450.
Okay.
And then this bottom one, it gets kind of tricky because so that 0.0625 divided by 12 is like approximately 0.005208. So you want to go out kind of as far as you can, because the more digits you have on there, the more correct. And if you're off by a few cents, I'm not gonna like mark it wrong or anything like that. If I can see you have the right idea, you have it set up correctly, and you're just off by a few cents, and that just means it just was a rounding error by your calculator. So, but yeah. So then you would divide all of that in your calculator by 0.005208 and then you should get something pretty close to that.
Okay.
Did you, or were you trying to do it along?
I keep pushing the wrong buttons and fat finger and everything. So
That's okay. We'll try it again because I know you're not alone. Other people are trying to do it too. So start with the 0.0625 divided by 12. Hit enter. Add 1. Hit enter. Raise it to the 360th power. Right, that's what that 30 times 12 is. Hit enter. Then subtract 1. Hit enter. Times it by the 450. And then divide, just keep all of that number in there, whatever it is, and then hit divide by 0.005208. You guys getting that? And it might just be like,
I don't know. It's still giving me random numbers. It's giving me like 5.17 whatever times 10 to the power of 94. I don't know. I was having the same problem when I was doing the exercises and stuff.
Let's see. And which calculator are you using?
TI 30X.
Let's see. I wonder what. So it's saying that you're like, because when it has it like, it's just telling you like you got a lot of digits there, right? But
Yeah.
it still should be something, that looks like, 474. Yeah. So
it's not giving me that.
Okay, because I think like some other people are doing it too. Do you want to tell me? So tell me what you're putting into your calculator then.
So you do the 0.0625 divided by 12.
Mm-hmm. And then hit enter.
Yeah. And then that's that number at the bottom.
Uh-huh.
And then add 1 to that.
Mm-hmm.
And then to the power of 360.
Well, did you hit enter?
Yeah.
Okay, because you always have to hit enter after each one, and that's where some people forget.
Then to the power of 360. And then that gives me 6.4891663881.
Okay.
And minus 1. And that's 5.4 whatever. And then times 450. 2470.12. And then divide that by the 0.0052083. And that time it worked.
I know.
Whatever.
You're like, how is this happening? I know. Like, I mean, if it is, I mean, I don't know. I know it's kind of late in the game since the test is next week, but you know, if you guys are able to buy this one or the TI-36 Pro, I guarantee that you're going to be it's just going to be so much less frustrating for you on it. And this one you can usually, well, both of those are like under $20. So if you're able to, I would say like try and get it. But I mean, it will work the other way. It's just, you got to be really careful. And usually the problem is people not hitting enter after every single part that you're doing. Because then it's like, you know, it's a calculator. It doesn't understand, you know, what you have to do there. So, just to, you know, I was trying to do what you're saying for it to do.
Okay.
But, did you get it, Maria? No? Okay. How about the others? Let's see. All right, let's look at one or two other ones here. I mean, because really it's just a matter of just, you know, knowing where to kind of put the numbers in and then putting it into your equation. But if you can get it set up for me, like you're going to get most of the points just by getting it set up here, right? I mean, you will get a couple of, you know, points from, you know, just from having this right answer here, but it's mostly like, I just want to see, do you know which formula to use and what numbers to put where? And if you can do that, then you will get most of the points on it, just so you know. Okay, so that's why it's super important that you show that to me. Okay, let's look at number 4 also. So this is how much can we withdraw each month, right, with from an annuity with $750,000 over the next 30 years. All right, so if we're using that, what I call the pork formula, right, we're going to have, so that P sub 0 is that start amount, all right? So this is what you're starting with. You're starting with $750,000 in your account, and you're taking out money every month for your retirement. Okay, so that's why that's our start amount. So we'll have $750,000 times by the interest rate divided by the times compounded. So 0.08 is our interest rate, all right, divided by 12. And then that is going to be divided by 1 minus, and then parentheses, 1 plus that R over K again, so 0.08 divided by 12, raised to the negative NK power. So that's going to be, so it's 30 years and compounded every month, so that's going to be 30 times 12 there, but negative 30 times 12. Okay. And so on this one, I mean, if you don't have a calculator to put the whole thing in, you're going to want to figure out what that top number is. and write that down with as many digits as you possibly can on there if it's like something that keeps going on and on. Right, so you'd start off by putting in 0.08 divided by 12, hit enter, and then times that by 750,000. And so on this one, it comes out nice because, yeah, 0.08 divided by 12 makes it nice. So that's just going to be 5,000 on the top. And then you figure out what the bottom is, and then you can divide those in the end. All right. So again, on this one, if we're doing this one, we start with the point. Well, make sure you know that negative 30 times 12 is going to be negative 360th power, right? Do that first. So, yeah, so start off with 0.08 divided by 12. Hit enter, add 1 to it. Hit enter. Raise it to the negative 360th power. So we've got to make sure that's raised to that negative power. All right. And then you're doing 1 minus that number. And so that gets a little bit tricky there because you have to do the 1 first. So 1 minus, it was like 0.091443372 and so on. All right, so then my bottom number here is something like, let's see, 8556628, and then divide those out, putting the 5,000 in first, right, and then divided by 0.908556628. So when I did it this way, I came up with $5,503.23. Right, and that's how much you can take out each month. All right, so like on retirement, you can take that much out per month if you started with $750,000 in your retirement account. Is that what you guys came up with? Something close like that? Okay.
Yeah.
Let's see. How did you guys feel about this type of problem on that project where you had to figure out what the down payment is and then figure out how much you're financing, and then from there figure out what your monthly payment would be? Should we try this one, or do you guys feel okay about that? Like how to do that type of problem?
I'd like to try it.
Okay, let's do it. Okay, so this one has a lot of different parts to it, but that's all right. Okay, so you find a townhome you would like to buy for $250,000. You will put 10% down. All right, so first thing that we're going to do, so the first part, right, is we're trying to figure out how much we'll be financing, but we've got to figure out how much we're putting down first. So I'm going to have 250,000 times that 10%, which is 0.1. All right, so that's going to be 25,000 is how much the down payment is, but that's not what it's asking. It's saying how much will you be financing. So how do we figure out how much we're financing?
Subtract that.
Yeah, so right, you're doing, and I'll write it down here just to make sure everybody sees where the numbers are coming from. So I'm subtracting that off. All right. And so that means we'll end up with 225,000 is how much we're going to be financing. Okay. Then the second part, what will the monthly house payment be? All right, so that's where we got to use that PORC formula for that. Okay. So when we do that, that's going to be So the 225 is our start amount. That's what we're going to be putting in place of that P sub 0. So 225,000, and then times the rate divided by the number of times compounded, right? And I said it's always going to be 12 unless it says otherwise. And what's our finance rate here? 0.0325. Oops, 5 looks kind of weird there. Okay, and then we're going to divide that by 1 minus parenthesis 1 plus that same thing there, that R over K, so 0.0325 divided by 12 raised to the negative 360th power, because it's still 30 years and 12 months. All right, and make sure you have it as negative. Okay, then again, like you just put that in your calculator, kind of the same way that we did above. You guys try it on your own this time and see if you come up with, yeah. So write down some of those numbers and take out as many digits as you possibly can to get it close to the right answer. Okay, did you guys get something close to that? $979.21.
Yeah.
Okay. And then let's see the third part. How much will you pay for the house if it takes 30 years to pay off? All right, so how do we figure out how much we're gonna like actually be paying for it? Because we're financing 225,000, but we're gonna be paying a lot more for the house than that, right? Anybody remember, what do we do? Take that monthly payment, that $979.21, and times it by however many payments we're going to be making in 30 years, right? And that's going to be 360 because we got 30 years, but a payment every month, right? So times that by 360. So let's see, did you get 352517.12? Oh, sorry, I accidentally put the I left the number in there and I didn't have it like truncate or at 0.21. So it should be 352515. 0.6, 160 cents. Okay. So that's how much you're going to be paying for the house. And that's like if you always make the minimum payment, right? That's how much you'll pay. And then the last part is how much will you pay in interest? So how do we figure that out?
Subtract the the 250 from it.
Uh-huh. Yep. So 352, 51560 minus the 225,000. All right, because that's the amount we financed. Okay, so I've got 127,515.60. So that's a lot of interest to pay, right? So lots of interest. Over $100,000 or $125,000 just in interest, right? Where if you can put like, like $100 or $200 each month more on it, as you saw in that project, it goes down significantly. You're just paying a lot less interest on that. So, okay, well, I think probably stop there, but like I said, I'll send you some of these things. I'll put them actually in that exam 2 module. So this will be in there, and I'll put the answers on these other ones as well so that you can check to see, if you go through them, if you are getting the answers correct. So look for that. And then I'll give you a couple other things to kind of look at for like growth, those growth models and stuff like that. And again, it'll have the answers on it so that you can kind of check and see that you know how to do those. Okay. All right. But if anybody wants to stay on, if there's any help I can give you with your calculator, I'll definitely try on here. I know it's kind of hard over Zoom, but I will do the best I can. Okay. So, and if you have any other questions too, feel free to ask before you go.
Thank you.
You're welcome. Thanks so much for coming, guys.
You.
See ya.
Thank you.
You're so welcome, guys. Have a good night. Okay, so I'm going to go through with you just like step by step and see what numbers you're coming up with when, so I can kind of see maybe what is happening on there. So when you tried this one, were you able to finally come up with that? No? Okay. One other thing that I want you to check for, it shouldn't be an issue on this, but yeah, I don't think it's like cutting anything off. Let me see.